So now it's time to hear from one of our founders, Srini Srinivasan, who's going to, and also our chief product officer, is going to talk to us about kind of where we've been on the product side and where we're going, and give you a pretty good preview into what's coming ahead. So Srini, welcome.
10 years. You know, these are the two words which keep coming into my mind. It's about 10 years since we started the company. And the reason these words come to my mind is because I once listened to a talk by Mike Stonebreaker, who's one of the great database innovators of all time, in my opinion, a Turing Award winner. He once gave a talk, and he's built like several databases, not just in research, but made them production in like Vertica and many others. But the point he was making was, it takes about 10 years to build a database system of consequence. So I want to take you through initially, and I'll let you make the judgment of whether, you know, what Aerospike has done over the 10 years, briefly, you know. And you can determine whether we have done something of consequence and whether it is a database system of consequence. I believe it is. But I want to make the case in a few minutes. When we started, as John mentioned, we essentially wanted to solve some of the hard problems which we felt needed to be solved in order to get all of these users to the internet age, so to speak. You know, and this is not something we started. We were caught in the middle of it in other companies. You know, both myself and my co-founder, Brian Bulkowski, you know, we were internet companies. We met, and we decided that, you know, due to the technology innovations happening in storage, we would be able to build a database which was 10 times faster and 10 times better or lower in terms of TCO at the same time, giving us a 100x advantage. A 10x advantage, in our opinion, was not enough to start a company in a field where even, you know, experts like Mike Stonebreaker say it'll take 10 years to build something of consequence. So we needed a 100x advantage, and we got that, you know, thanks to the work of many of our partners today in the hardware space. When we started, our goal was to hit a throughput of 1 million transactions per second. That's where we started. You know, latency sub-millisecond. You know, why is this important, right? I mean, every day, you know, as John again mentioned, you know, you have all these devices, people carrying around mobile technologies, and they're using, you know, it in their daily lives, and nobody wants to wait. And this whole idea that we have to do things fast is something, I don't know whether it's a good or a bad thing. I'm not here to place judgment on it, but that's where human beings have gone for the last 10 years. And we felt that supporting that, it would actually be really important. And as many of you in the audience are pretty much experts or at the state of the art in this area. Reliability, right? Over the last 10 years, we've had deployments. The first deployments we made, you know, our customers essentially started, and you know, we have one of them speaking in the follow-up session from the trade desk, and they've been running for 8+ years with virtually no downtime. You know, typically it is a hard problem to solve, and there were obviously a lot of hiccups along the way. But around 5 years ago or something, we reached a point where we could potentially run a high-performance system at scale, day in and day out, with virtually no downtime. And that was an interesting kind of milestone. Scaling up to petabytes is something we did more recently. Essentially, you know, we started with a 10 terabyte database potentially, and then, you know, at the maximum level, you know, there were people doing less than that in 2010. We started going to 100, and last year, you know, it was a petabyte or close to that. And so over the years, you know, essentially what happened, I don't know if this thing works, I don't know which one to press, so I'm not going to press it. So I'm just going to point. So if you look at the left side of that picture, we have the edge part of the database. This is where the high throughput, low latency, high uptime applications run. When you're kind of logging into your bank account, you're transferring money, you're basically, getting an ad on your phone. That is the side where Aerospike essentially started in. Over time, what happened is, in order to expand businesses, many of our customers became global. They ended up having, to deal with the entire world. And the world, I think, different people sleep at different times. There's a time zone difference. There's a different way of accessing it. There is delays between these various geographically distributed installations. So they ended up having a whole bunch of edge-based systems. And over time, you want to actually not store all of your data all the time on all the edges. That is particularly wasteful if all your data for users in the West, let's say in North America, are also stored in the same servers which serve Asia. Why do that? So the concept of having a real-time system of record, and I think some people call it a cold store, but a place where you have all of the real-time data, which can be updated at very high rates, can exist, and then move to the edge as needed. This is a better and a more sustainable way to run these systems, because edge systems are very expensive. You have to use the best in hardware, and you need to have a lot of them. And moving data between these edge systems at scale, where you move all the data everywhere, is going to eat up a lot of the bandwidth. So people started, this whole real-time system of record started as a cold store, but then eventually people find out that if you can actually run Aerospike on a cold store, you could essentially have a fairly fast system. As some of you attended the training sessions this morning, there was one session where we talked about all flash. I'll talk a little bit about that here. So what you end up having is a system which is a single source of truth, which is funneling data to all of the edges, so you can kind of run your business in a much more, what I would call, real-time manner. Fast forward, right? Now that you have a system of record. Now, this one point I do want to make is the system of record we are talking about here is not replacing your traditional system of record where you, like typically running on relational databases and so on. This is a real-time system of record which has enormous scale, and it serves to communicate with edge databases. But once you have such a system of record, it needs to communicate with your other systems of record in the enterprise. And that's where we started kind of working towards essentially communicating, building these connectors. We'll talk a little bit about that product line, the Aerospike Connect line, and so on. And then we would definitely have to talk to the legacy data stores. So this is essentially what the Aerospike ecosystem looks like. And what you will see in the roadmap is our kind of progress so far, but also how we are planning to address and expand over the next year or more. The one point I do want to bring up is strong consistency. Essentially, a database needs to keep its data safe, and that is actually the most important thing about a database. The fact that we are fast is a bonus, so to speak, which allows you to tackle problems you cannot tackle with other strongly consistent databases. And that is really important to understand, is we have opened up a window where applications can now solve problems which could not be solved in a cost-effective manner before. And finally, what I mentioned first was you have a TCO advantage, mostly because of the hardware manufacturers who have built all these wonderful technologies which we are able to leverage. And I'm going to spend like a few minutes on some of the details of how our product has leveraged hardware technologies. If you think about Aerospike, our approach to a problem is to always make it more efficient. But we also recognize, we've always recognized, that we are not doing this alone. We're pretty much standing on the shoulder of giants who build a lot of interesting hardware technology, especially in storage and memory and networking and so on, and also processors. So when we started the company, we had these two modes, essentially, which is keeping all your data in memory, which is pretty much what everybody else does, but also have a hybrid system where we can store data in flash and just the index and DRAM. And this provides an amazing amount of TCO, but also provides you near memory performance by being sub-millisecond and so on and so forth, with major parallelism adding to the fact that you could run 1 million transactions per second on a node with tens of terabytes of data. what happens then is, again, this came up in the training sessions this morning. We decided to put all our indexes on flash. Now, when you put the primary index on flash and the data is on flash, it's a little bit slower, but it's still sub 10 milliseconds or so in terms of how you can read and write. And that's actually an enormous cost advantage when you have a trillion object database. So we're now starting to push the envelope to petabytes and so on. And then we have Intel, which has come up with the Optane DC persistent memory. And we were the first people to jump on it in terms of having a production version available for use. And what we do there is have the ability to store the index in persistent memory. This immediately gives you an enormous advantage. So think of all of this as a way for Aerospike to essentially leverage hardware innovations in such a way that we can bring those performance advantages, in this particular case, if you store data in the index in PMEM, we are able to restart the system very fast. There's one point I want to emphasize. When we look at a new technology like persistent memory, Aerospike is not interested in just using it at the top level. Right? It's very easy to use persistent memory as simply an expanded version of DRAM, which is what pretty much everybody else does. What we wanted to do was use the persistence features of PMEM in addition to actually make that extra difference that only applications running on Aerospike can get. This means that if you actually use Aerospike, you are guaranteed that we're going to take full advantage of any hardware advances that come along. We're not going to stop halfway. And that's really important. For somebody who's going to bet their business on a mission-critical infrastructure like Aerospike, you want to have that level of confidence that we are not going to we're going to go all the way in our leverage of these technologies, and that's really important. And there's one more I want to talk about. This is John talked about wireline speed. This is actually a phrase from my co-founder. I don't know if he coined it, but he used to use it all the time in the first few years. It was always about wireline, and the idea is very simple. We in Aerospike, we run on a shared nothing architecture, as most of you know. We run on a node. We use processors, we use memory, we use network, we use all of these storage. We do not want anything in our system, in our nodes, to be the bottleneck. We want the network to be the bottleneck. And the network advances keeps going up and up, which is what basically means that as your network advances go up, Aerospike essentially is able to take advantage of it. This is a slide I actually, which I think Intel presented to the press a few weeks ago. And all this is about is having, I didn't say this, I should probably have said this before, but in this picture, what Aerospike does is we do a lot of work in terms of aligning our threads to NUMA domains or CPUs and cores and all of that, right? We do it all in software. We figure out, how Linux works, and we attach it and so on. And we get some level of performance to it. And then, good old Intel comes up with this idea that, we're going to do all of this in hardware. And here's a network card, which is going to align you with various threads automatically. And we ended up showing, I think, about 30% more in terms of transactions per second on a single node, to the press, which, meet that Intel had on interconnect day. And it was about 12 million read ops per second on a single node with 2 Aerospike server processes running on the 2-socket node, So this is essentially what you can do in terms of optimizations. And a lot of the work here, I should thank Intel because they did most of the work in terms of running Aerospike on that architecture. But we're going to reproduce it too. They've sent us the cards. Now, let me switch a little bit. What is it that we have delivered last year? Last year, if I would actually rate our productivity, I think it was the most productive in terms of our engineering output than the first 2 years we were in business. The first 2 years, nobody can compare with that. That is like crazy startup stuff. We were doing like 200 things at the same time. We somehow got through it alive. But at the end of which, we had customers like AppNexus, the Trade Desk, and a whole bunch of people in Japan. I think our first customer from Japan is here, Sonet. So we just got like worldwide in China and India, InMobi, for example. That was like a crazy year. So we can't compare to that. But this was the second most productive year on a product which has already been in deployment for 7 years. And we produced, and I have to give complete credit to our engineering and product teams to have delivered this, okay? So you see what happened last year, and you know, many of you are using the product, so you know a lot of it. So I do want to point out that in the beginning I pointed out about TCO. The idea that you can run Aerospike for a cost much lower than anything else, the reason to buy Aerospike is not about TCO. The reason to buy Aerospike or use Aerospike, or you know, some of you use the community edition, you don't even have to buy it. But the point is, it is all about solving a problem at scale in a practical way for a company that's not a Google or a Facebook, even though there are people here who are as big as Facebook or Google, but I'm sure, but you have to run at that scale. Pretty much anybody can use Aerospike's technology and get to that scale without switching out the technology for anything else for a set of use cases. And that's fundamentally important because when we added, for example, all-flash, we reduced your TCO for a trillion object database. When we added uniform partition balance, you know, again, it was mentioned in one of the training sessions, we increased the headroom on some deployments by 30%. You know, we added storage optimization. Essentially, we ended up getting people calling us saying, half my data is not there, but they were there. We just made it more efficient. So we always think about this, okay? You should expect us to continue to improve the product, even though you haven't changed your hardware, your actual cluster's capacity continues to increase. And that's the magic of software, of course. That's why software eats the world, right? That's kind of the saying from Andreessen. Anyway, so we try to kind of do as much as possible there. We've also kind of moved forward on strong consistency by relaxing. This is a classic database concept. To relax strong consistency, especially for certain kinds of use cases. But I'm going to highlight, I already highlighted a few of the benefits here. One of the important things is we have a feature last year which we released called quiescing the database. For a long time, right, Aerospike has always been adaptive, so you could always take a node out, bring it back in, but you would end up having some timeouts. This means the application people who are monitoring it in many companies would actually start yelling at the operator saying, what are you doing, right? So one of the things Aerospike has always been sensitive about is we want to make it as easy as possible to run a service on Aerospike, which is real time, which means we need to handle that. So quiescence took a while coming, but now what you can do is if you have a maintenance on the Aerospike cluster, you could do a rolling upgrade on the system with 0 timeouts. You didn't mishear it. It's 0. Essentially, your application runs, you take a node out, you basically quiesce it, you wait out, and then all the existing transactions continue. The node is still there. It goes at the end of the partition list. A little bit technical, but essentially there is a partition map. We put it at the end of the map, so it's still there. It's full in the terminology that we use, but it doesn't take any more writes. All of those writes will go to the new node, you know, the next one in the list. And that's really important. What end result is, the application people don't even know when the operators are actually doing this. This is goodness, because essentially you can run your business. You know, you don't have to wait till the middle of the night. You don't have to do all these weird, what do you call it, time-bound maintenance. You can do it whenever you want, and this takes us to the next level. Again, I talked about the storage compression, not compression, the more efficient storage optimizations we did in release 4.2, I believe. Uniform balance is a way, again, I talked about how it increases the capacity of a cluster because you now don't have nodes which are skewed in terms of load they are taking because of the non-uniform distribution of partitions. And this has been a huge win, and we're probably going to make this default. I don't know if it's already the default, but it should definitely be a default going forward for all installations. The other big changes, other big additions we have done is on the Aerospike Connect side, where we enable Aerospike using change notification to communicate with other databases. For a while, we've had a connector which can feed data into Aerospike, because we can take heavy loads. It doesn't matter. No other database actually can take the load. So whatever anybody throws at other databases, we will be able to absorb it. The reverse, on the other hand, requires a little bit more calibration, because if we take all the data coming into Aerospike and we push it out, well, we got to have another Aerospike on the other side, you know. So we got to be careful, but we have added connectors to do the change notification. We'll be enhancing that. I'll talk about that in the roadmap. I only want to talk about one use case last year, which is kind of, to me, as a database person, the first time I took a database course, the most interesting thing about the database course was you can actually transfer money with it. Because you don't want to lose a money transaction. It doesn't matter who's doing it, where, when, how, right? That is just not acceptable. And there was a problem, and what is the problem of an instant payment settlement? I mean, there are people here who are about 10 times more of an expert on this topic than I am, but I'm going to just explain what this particular customer was thinking, right? So what they wanted to make sure, first of all, they're building a system to transfer money in small euro amounts across any two bank accounts, any two users in Europe. That's what they're trying to solve. Now, they had to satisfy various things. One is you cannot ever lose a transaction. That's important. Okay. Number two, it needed to be highly available across multiple data centers. What you cannot do, and you cannot have an inconsistency between the two data centers. Okay. And it had to be high performance enough that they could essentially be able to do this whole transfer within seconds, which means the database access times are sub-milliseconds, and they can handle, and they need to do it persistently, which means you needed to have this hybrid flash configuration helped, but a whole bunch of requirements like that which we could match. And finally, they needed to make sure when you transfer these euros between each other, the total amount of data that the total amount it costs is a fraction of a euro cent. Otherwise, it's not cost effective. If you're transferring $1,000 of money, you can expect to spend $1. It's fine. But if you're not doing that, so that's kind of what they had. And that's essentially what they ended up using Aerospike for, is we satisfied all of those requirements due to strong consistency, which made that work. Hybrid flash brought the cost down enough, but also the ability to run a rack-aware stretch cluster across two data centers, which were about 10 kilometers from each other, was enough to pay that little bit extra latency of a couple of milliseconds, but still within the frame of actually having a completely consistent system. Some other customers of ours are also moving to that thing. And this is publicly available. We can give you the link. You can go look at it, what exactly TIPS is. So let me now talk about the roadmap for the next year. So I want to talk a little bit about our product process. This particular picture is a 5-quarter roadmap. It starts at the beginning of this year. So Q1, already the relaxed consistency thing is out, so you can read it. But the point I want to make, and I'm going to go into details of what these are in a second. We get a lot of requests for features from customers, partners, our own research, storage vendors, who keep coming up with all kinds of interesting stuff, and we have to adapt to it, right? But then in the core product, it takes a long time to do anything. I mean, when I say it takes 10 years to build a database, I mean, this is like not me saying, right? I mean, this is true. It's hard to build something. The reason it's hard is because every time you add a feature, you got to make sure everything else works in conjunction with this. Our head of engineering, Andy, has a nice kind of picture he drew on the board once as to like adding a feature in strong, like a rack-aware feature, I think, in strong consistency, which ended up kind of having this enormous like tentacles into like 25 parts of the code. And to do all of this right requires a lot of thinking. One cannot simply add the code and figure out how to test later. So there's a lot of thinking and designing going on, and sometimes we have to redesign something in order to make it work with something else. We need to put that kind of effort in. So it takes a while to do the core features. So we plan it once a year. We decide once a year, and every 6 months we do a little bit of really minor adjustments in the core stuff. We can't do major. Okay, so that's one thing to you is please do. This is a once-a-year conference, so this will be a time for you to try and influence us as to what is interesting to you. But I'll get to that in a second. So we have themes. I won't go into all the details yet. Speed at scale. This is what we do from the beginning. XDR and tiering. You saw that picture with the edge and the core. Tiering is all about moving data back and forth between the edge to the core, across edges, from the core to another one where we can do maybe queries. So essentially, it's a lot of movement going on, and it is more than just connecting them. It is also the ability to seamlessly subset data at different levels across these clusters. And I'll go into that in a second. That's XDR and tiering. And query and secondary index is really important for a database. As we go into more system of record use cases, we fully expect, and we've already heard from some of you, that you would like more sophisticated access to the data we already store in terms of querying. And we've heard you, but it is going to take a while to get it right, and I will talk about that. And also, as we go forward, we add more features which are helpful to developers to build more interesting applications. First thing, we've already released this, is a relaxed consistency for reads. The idea is to allow you to read from a replica, as well as read from data which is not available, which means you could get a little bit of stale data. If it is all right for your application, you're still perfectly guaranteed that the data is safe in terms of writes. There is no inconsistency in the database. However, your application might be able to survive with a slightly older value, so you're now more available. Performance is the same. Virtually the same. And still there are no dirty reads. We're also improving the way we are compressing and storing data. So our data formats of how we store the data was different than how we send the data on the network between clusters, between cluster nodes. We're going to fix that, but that automatically means that compression now can be sent over the wire too. So this actually improves our performance quite a bit. Scans have been, I think, a little bit of an issue for many of you because we don't do them in a parallel manner. What that means is a large scan can get behind a small scan, and which means, or vice versa, right? I mean, it's the other way which is worse. A small scan getting behind a backup means that you got to wait until the backup is finished before you get it done. Those things have to be changed, and we're working on that. And also, can I make a large scan go faster by, splitting it up and so on. There's a whole bunch of work to be done there. Also, we are working on various ways of limiting application access to a database in such a way that you can have multiple applications work against the database without interfering with each other. And this is, again, an operational kind of issue because a new kind of application coming into your production. Many people use tests on production databases. I mean, it's pretty common in the industry I come from before Aerospike, like, in the internet industry. So you need to make sure that there is no such application which can just take over the entire system. And so we will work on fixing that. So there are a whole bunch of things we can do there. We will also add support for storing all of our data in persistent memory. And there's and there was a question this morning about, are we going to do compression for in-memory data storage? At some point we will consider this. We probably might consider this as part of this. It's mostly because we want to kind of unify the way we deal with PMEM and memory in terms of how we do the algorithms. But there's just a matter of positioning and, timing and so on. In terms of XDR, we're going to do it in 2 phases. Each of them is going to take like 3 or like 2 quarters each, I think. We will integrate the core database and eliminating separate. OK, I'll back up. We have strong consistency now. We also have a way to do digest logs in XDR. Okay? As you can, some of you are experts in databases. You can figure out now there are 2 schemes. Right? So we're going to unify the 2. We're going to make sure that the strong consistency scheme of Aerospike is in line with how XDR deals with it also. And that's one of the decisions we made was to eliminate a separate log for XDR compared to how the algorithms which we use for strong consistency, which actually uses bits and various other storage kind of artifacts in the core database. We are going to make sure that these 2 work well together, and it'll only appear in phase 2. So we will have what I would call as a rock-solid, active, passive, strong consistency system. So you will be guaranteed. It's not like eventual consistency. It's essentially you will be guaranteed a level of consistency which essentially is the best you can get in such a system. Okay? So that's where we are working towards. We will also add other kind of popular kind of requests, like dynamically adding data center configurations, et cetera, and shipping information, and so on. We will also, improve the correctness in failure situations so that there will not be, essentially you have one cluster running in one data center, another one running somewhere else, and you don't want transactions to cross over when you're shipping it across these clusters. And those are things we can prevent 100% of the time, hopefully. We will also add filtering, and this is something I alluded to. If you want to move data back and forth in the system, you want to have sophisticated filtering, given that we can't dump all the data in Aerospike into something else and filter it there. That's not going to work, because the amount of load we can take and pump outside is too much to do it outside. So we're going to have to do it inside. We will do that. We will also add features to predictably say, hey, I want to have these two clusters synced up as of this time. So we will be able to do that. We don't have those features today. But all of that we are able to add going forward. In query and secondary indexes, this is actually a topic which is very close to my heart, because when I started my first ever database job, I was basically working on query optimization. And it's a hard problem. We're not talking about optimization here. We are more talking about how can we make it fast first. Our indexing, this is all about secondary indexes. How can we make the queries faster? We believe we can get a lot of improvement in terms of reduction of the index size that we use, as well as improvement in performance, and make it more correct by when you delete an index entry, it'll go away immediately instead of it gets garbage collected later, and you might have some issues there. Reliable queries. This is even more important. Again, in the training session this morning, some of you must have heard how you have to worry about a node going down in the middle of a query, and then you have to restart the query and look at what's going on. All of that will go away, because we will be able to ensure that any point in time you can continue a query from where you left off. That's one of the side effects of this. But we'll also automatically handle when the cluster changes in the middle of a long query. We'll know how to get you the right set of data, which is it is not going to be serializable or linearizable, because that means we would have to basically not allow any writes in the database, but it is going to be enforced there are no dirty reads and you don't miss data. So all of that I think we can enforce. And over time, we will add warm start. We will add the ability to store secondary indexes in all flash, as well as in persistent memory. We are working on multiple advances to the programming model. Some of them are about the complex data types. I think there's been a lot of requests to do more nesting, the nested level accesses for data types. We're going to add a whole bunch of features. I think those of you who love to program at that level would really love it, we hope. But do give us feedback. Bitwise operations, this is something which has been available in competitive products. And I think we can actually add it without too much of a problem. So we're going to add this also. Conditional key value operations, again, this is about completing some of the the filters that we use today for various operations. For example, we can't run filters on batch reads today. You can run it on scan and query. We're going to add that. What about writes? Why not we check what the data is before writing and then ignore the write? And you can even write it with multi-operations on a single record. Okay, so you could essentially push more of the processing close to the data, and you will see more of that happen over time. But this is I would say these are baby steps, but this should significantly improve the ease of use in certain kinds of applications which would like to process data close to the actual storage. In addition to, I'm going to switch and go to the connectivity to other databases, legacy databases, and other systems. And we have multiple themes here. Once again, it is like a 5-quarter kind of roadmap. We essentially will be working on really 2 streams. It's Connect and Cloud. We also have additional things like tools and plugins, which we will build ourselves. Think of them as reference architectures, reference implementations, which can also be used in production. But in many cases, people will look at it as examples and then build their own tools and plugins in some cases. Okay, so that's the possibility here. And in terms of Connect, our philosophy of looking at Connect is divided into 2 kinds of 2 categories, basically. The first one is, how do you interoperate with existing data stores? This is about just sending data back and forth between these data stores. The second one is power existing apps. To some extent, Spark falls on the existing app side. Kafka falls on the interoperation side. And there are a whole bunch of other things. We only have done a few of these, but this is kind of where we are headed. Okay, in terms of how we look at the problem and what you want to do there. In terms of Aerospike Connect, we are focusing on a few categories. The first one is real time. So whenever Aerospike is used, it's used on the edge of the system, or even at the core, it is expected to take a lot of real-time load. So we will work with other systems which are also real-time focused. And that filter is what we used to, for example, pick this set of integrations. The first one was JMS. JMS is particularly attractive because multiple message queues work on the interface. We found two of them our customers need today. One is Solus, another one is IBM Message Queue. Flink is the one after that. We already have an internal kind of implementation, but this is, when I talk about this is all products coming out. And there are multiple ways to use Flink with multiple programming languages. We'll support all of those. Connect for Spark, we're adding PySpark support. We already have a Connect for Spark. This is an incremental addition. And also Elasticsearch, which I think is used quite a bit today alongside Aerospike. And we would like to make it much easier for our customers to do that going forward. So the real-time focus gives you that. There are things we don't have there, like general integration, what I would call a federated query kind of tool, which if it's not real-time, we don't necessarily focus on it right now. Eventually, I'm sure we'll get to all of that. The other focus we have in Aerospike Connect is to find areas of applications where Aerospike is really well used. And as pretty much most of you know, Aerospike is heavily used in machine learning, and AI applications in terms of like creating models and applying the models, using the data in the real time to produce, maybe improve the model. This is essentially a huge use case for it. So our goal is to try and find tools and infrastructure which are used in these areas and make it easy for Aerospike to be used with those. So you see that in the Connect for AI ML. And if you have any way, you have suggestions on this, feel free to reach out to us. Easy integration. This is important. It'll be, for me, it should be possible for you. You could give up some performance. It should be possible to integrate your application into Aerospike without having to write any code. If there are tools like that, we would integrate with that, and that's kind of what the REST client is all about. Working with Spring, Connect for Hadoop, that's a refresh. We already have that for a couple of years. The Aerospike Cloud is possibly the most important product initiative we have in the sense that we are attempting to make Aerospike as easy to operate as cloud-native databases. To give you an example, on Amazon, we want Aerospike to manage a service on Aerospike to be as easy to operate a DynamoDB-based application. On Azure, we want the same thing, as easy to operate Aerospike as Cosmos DB, for example, and Bigtable on Google. Okay, pick your cloud. But that is the goal we have set for ourselves. And fundamentally, we don't, and of course, Aerospike is able to work on all of these clouds, and that's actually a good thing. So from a customer point of view, you should be able to make it really easy. And that's where, if you look at the set of items you're working on, it's kind of fairly obvious. We want to make sure that we can manage your clusters, automatically. Monitoring is better, alerting is better. But we can also scale up and scale down. You should be able to go to a cluster and say, you know what, I want 25% more capacity. Or go to a cluster and say, I want to reduce it by 50%. And it should be, and given we have homogeneous clusters, we should know what instances on the cloud you have, and we should be able to go up and down. You might have to give it some permission to do this, but essentially this is something we will do. And also automatically backing up, rolling upgrade. All of this we will support at the product quality that will enable all of you to manage an Aerospike service much easier. And some of you, I know, is coming too late for you because you built all this yourself. I'm sorry about it. But we've woken up finally, I guess, and realized that this is actually the future for us. We also do other things, like Kubernetes, I think, seems to be really popular, so we will try to run it everywhere. So the idea is you can run things on your data center, you can run it on Google Cloud, you can run it on Azure, et cetera, and you will be able to use the same tools. So that it becomes easier. So you can go do other things. I'm sure there'll still be gaps, and we have our client services team, which will do their best to fill in those gaps to make it easier for you to deploy. So finally, I come to the longer-term issues. So that's kind of what we are doing for the next year. But then I was thinking, how was I going to close this session? I was going to give you I mean, not that you need more work. I was going to give you some, an action item, if you will, for you to think about, okay? We have enough work to do for the next 5 years, in my estimation. That's not the point. The point is, there are a lot of things we could do, right? And here are some of the things I can go over, right? I mean, on the enterprise edition, we could do, add more consistency in an active-active setting across data centers. Because right now, if you do active-active, and then you have to have consistency, you're going to stretch a cluster across these two things. If these clusters are like, far apart, East Coast, West Coast, you have a 200 millisecond delay or something, and then your each transaction read is going to be potentially 200 milliseconds. I mean, you could do better with the rack aware, read it on locally, but the write's going to be. If that's okay, we have a solution today. But if you want something more sophisticated, but also limited in terms of functionality, it's both sophisticated in terms of consistency, but limited in terms of application usage, CRDTs could help. We look for feedback from you. So all of this, none of this stuff is actually decided at this point because this is really beyond the first year. Native support for aggregate functions is fairly obvious. UDFs, interesting. Think about it. We would love to support more ways of user-defined functions. What would be interesting to you would be interesting for we think WebAssembly is a good one to do. Java, of course, is like the holy grail to some extent. If you can put Java code and then you can run it on the server, you know what? I don't have to write complex application. I can have very lightweight applications. That seems to make sense. Probabilistic data types. Distributed global multi-record transactions, is that interesting? Because think about it this way, right? Aerospike is a database. It's not like we don't like to do the stuff relational databases do, like multi-record transactions, distributed transactions, so on. There is a hit we will have to take in terms of like the performance. And we're okay to do it if there are particular ways in which we can optimize these, provided applications can use them, Today, if you have to run Aerospike, you have to convert all your relational schemas into a single record kind of schema type and run it in that way. And you get extremely high performance, you get distribution, you get a lot of benefits for it, but you still have to do that. How much are you willing to give up in order to get a distributed multi-record transactions? I'm assuming you don't want to give up as much as you're giving up with the traditional databases. If you do, then we already have a solution, which is, you can use any database, right? So we're interested in some kind of feedback on those. And we have other things, like the multi-level clustering is interesting, right? One of the things I keep hearing from customers and other people, in the industry is, I want to solve this problem today, then I want to do 10x, and then 100x, and 1000x. This is literally one of the largest companies in the world. I was talking to one of their lead operations person, and he said, like, he got this problem like 8 years ago, and he has done it. And he says, you know what? It's happening again. I'm supposed to. So what is it that you think about this? We believe we can do this, by the way. I'm not putting anything here which I don't think we can do. Okay? But it's going to take effort. It's going to take some creative thinking and also prioritization. And that's where I would love to have some input. And then also time series support. It's fairly straightforward. Kerberos is one of those things which we didn't do earlier. We might do. Aerospike Connect. There are a whole bunch of things we could do. In terms of pieces, and there's a cloud-native cloud foundation. I always forget. So there's a whole bunch of work going on. We would love to know your ideas on whether we should do it now or not. And then Aerospike as a service. As I said, our goal is to make sure each of you can run Aerospike as a service as easily as possible. We could also run one, at some point. But we're not going to do it without actually having some of the deals, some of the functionality I listed in the cloud piece. But then, is that something which is interesting? Deeper integration with Kubernetes engines, this is pretty, and there could be more. And this is where I think I'm soliciting feedback. Finally, I will close by introducing the team here a little bit for two reasons. But let me first introduce the team. Can you folks come over? Can all of you come over? Because I'm not going to do one by one. This is like too long. Okay. So I'm going to introduce them in the order I was planning to do it. You can stand wherever you are. It's fine. So this is Andrew Gooding. Is the most. Okay. So a couple of words on Andy. This is our product team. So first I'll start with the engineering people. I was going to start with the product, I'm sorry. Start with engineering because Andy's been here longer. He is the prime force behind most of the things I talked about in terms of how to develop our product and so on. Okay? And he's been with us for almost 8 years. And then there is Sunil. He heads the engineering team in Bangalore. So Andy is the overall head of engineering, and Bangalore and Mountain View are in different time zones. So even though they actually work very well together, all nights and days and all that, I don't even know how they do it. But Sunil's been also with us for about 8 years. And then there is Joe. He's kind of the kid on the block, been here for like less than 2 years, right? Or 2 years or whatever. But he runs the Aerospike Connect and cloud engineering. These are the 3 engineers. I mean, and then there is, in product, I'm kind of owning, so to speak, the actual product management for the core product. But my helper is Meher, who is actually, you know him as the VP of Operations and Support. But he's actually the most knowledgeable about the core product in the company because of how, especially about how customers use us. So we basically work on the core. And then this is Ronan, who leads all of the product management for Aerospike Connect and Cloud. And he's newly got promoted, so thank you. And finally, I want to introduce our one person who works on our technology team, Paul Jensen. This is his first day. So, okay. Welcome. Okay. So, yeah, Meher and Ronan have been here for about 5+ years. So all I wanted to do was introduce them and let you know so you can put faces to, to names, but also the list I showed you, the one I showed you here, hopefully it'll show up. Did it show up? No. Okay, this one. I don't even know how this thing works. Okay. Okay, it showed up. You can go approach any of us, okay, and then talk to us about any of these things on the list, or the stuff I showed before on the coming year, or something you think should be done and we've completely missed. In fact, many of our customers do that, and prospects especially. They just want everything before they buy the product. But the point is, please do talk to us in the next couple of days. This conference is for you. We are here to help you and listen to you and learn. And so we can go back and figure out how to solve the problems that you think are important. So thank you. Okay.